So here's the thing about the American Revolution. Everybody talks about the battles, right? Lexington, Concord, Yorktown, the Declaration, the Founding Fathers, the birth of a nation. But winning independence turned out to be the easy part. The hard part, actually defending it afterward. Before we continue with the video, if you're listening right now, help me prove something wrong. My wife said I wouldn't even reach 1,000 subscribers, but I believe stories about old machines like this deserve to be heard. Help me show her that these videos matter. Please subscribe to our channel and let's keep these old machines' legacies alive. Picture this. Philadelphia, 1798. The United States is 22 years old, barely out of diapers as nations go, and already facing an existential crisis. France is threatening war. Britain still controls forts on American territory and is actively hostile. Spain sits on the Mississippi, choking off Western trade. Native American nations are resisting. Westward expansion, and honestly, who could blame them? The young republic needs an army, a real army, which means it needs weapons, lots of weapons. Here's the problem. American weapons manufacturing in 1798 was, well, let's call it artisanal. You wanted a musket? Great. You'd go to a gunsmith, a master craftsman who'd spend 3, maybe 4 weeks hand-filing every single component. The lock, the barrel, the stock, each piece shaped individually, fitted individually, adjusted until it worked. The result was beautiful. It was also completely unique. Every musket was basically a snowflake. A trigger from one gun wouldn't fit another. A lock plate made in Boston couldn't replace a broken one from Virginia. If your weapon malfunctioned in battle, you couldn't just swap out the broken part. You needed a gunsmith time and tools. On a battlefield, you had none of these things. The math was catastrophic. The Army needed 50,000 muskets minimum. Current production from scattered workshops across the country, maybe 1,000 per year if you were optimistic. At this rate, America would be fully armed sometime around 1850, assuming no one was in a hurry to invade. Enter Eli Whitney, Yale graduate, inventor of the cotton gin, which had already made him famous, and through a combination of patent theft and legal battles essentially broke. He was brilliant, ambitious, deeply in debt, and looking for his next opportunity. He was also, and this is important, not a gunsmith. He'd never made a weapon in his life. He had zero experience in armory work. So naturally, in June 1798, Whitney approached Treasury Secretary Oliver Wolcott with the most audacious proposal anyone had heard. He'd make 10,000 muskets in 2 years. Experienced gunsmiths, the men who actually knew how to make guns, laughed outright. Impossible. A master craftsman might produce 30 muskets per year if he really pushed. Whitney was promising 5,000 annually, and he'd never made one. But here's the kicker. Whitney wasn't planning to make muskets the traditional way. He had something different in mind, something that would change not just how America made weapons, but how America made everything. He was going to build them with parts that were the same, actually, genuinely, identically the same. The government, desperate and running out of options, decided to gamble. They had no idea they were funding a revolution that would reshape manufacturing itself. Whitney's real innovation wasn't the musket itself. It was the method. The concept had a name: interchangeable parts. The idea that you could make components so precisely identical that any trigger would fit any lock would fit any barrel would work with any stock. Not similar. Not close enough. Identical. This wasn't entirely new thinking. A French watchmaker named Honoré Blanc had demonstrated the concept in the 1780s. Thomas Jefferson, then ambassador to France, had witnessed it and been fascinated. But no one had achieved it at scale. No one had made it work for something as complex as a military weapon. Whitney was proposing to do both simultaneously while having never made a single musket. Think about what this actually meant for an army in the field. A musket breaks during battle. Under the old system, that weapon is done, useless. The soldier's effectively disarmed until he can find a gunsmith, which on a battlefield means never. Under Whitney's system, you swap the broken part. 5 minutes, back in action. You need to repair 100 weapons? 1 box of replacement locks fixes them all. Training recruits? You don't need to teach gunsmithing anymore, just teach assembly. The implications were staggering. On June 14, 1798, Whitney secured the contract. $134,000, an absolutely massive sum, equivalent to maybe 2 or 3 million today. The delivery schedule was breathtaking. 4,000 muskets by September 1799, the remainings 6,000 by September 1800, 15 months to deliver the first batch. He'd never made a single musket. Whitney immediately realized he'd miscalculated catastrophically. The precision required was beyond anything available in America. He needed machines that didn't exist, techniques that hadn't been invented, standards no one had established. Traditional gunsmiths worked by eye and feel, filing until parts fit. Whitney needed exact measurements, consistent tolerances, reproducible processes, and he had 15 months. He vanished to Connecticut, to a site along the Mill River near New Haven that locals called Mill Rock. He built a factory, but here's where things get weird. He wasn't making muskets, he was making machines, milling machines that could cut metal to consistent patterns, trip hammers for forging, jigs to hold parts in exact positions, fixtures made from hardened steel. He was building machines to make muskets. Meanwhile, the government was getting nervous. Other contractors using traditional methods were already delivering weapons, slow, expensive, handcrafted weapons, but actual weapons. Whitney, nothing, just letters full of elaborate explanations and promises. The vision was extraordinary. The execution was invisible. His credibility was evaporating. September 1799 came and went. 0 muskets delivered. Whitney was technically in breach of contract. He should have been ruined. But something in his letters, in his descriptions of what he was building, kept Treasury officials intrigued enough to wait. He wasn't just promising guns, he was describing a manufacturing revolution that no one had seen before. In Connecticut, something extraordinary was taking shape. Whether it would work was another question entirely. The machines Whitney built at Mill Rock were unlike anything American craftsmen had seen. His milling machine could cut metal following precise patterns guided by templates made from hardened steel. Each cut identical to the last. The trip hammer forged metal parts with consistent force and shape. But the real breakthrough was simpler than anyone expected: the filing jig. Before Whitney, a skilled gunsmith would hold a lock plate in his hands and file it smooth by eye and feel. It took hours. Each plate came out slightly different because human hands aren't perfectly steady and human eyes can't see variations of a few thousandths of an inch. Whitney's jig held the part in an exact position, guided the file along a precise path, and let a semi-skilled worker produce identical parts in a fraction of the time. It wasn't about replacing human skill with machines. It was about embedding the skill into the machine itself. The jig contained the master craftsman's knowledge. Any worker could use it and get the same result. This was revolutionary thinking, and it was happening in a Connecticut factory while the government waited impatiently for muskets that still didn't exist. The 1799 deadline passed. Then 1800. 0 muskets delivered. The government demanded answers. Whitney wrote brilliant letters explaining his vision, promising a revolution in manufacturing, begging for patience. He was in breach of contract. He should have been sued, maybe jailed. But he was also describing something unprecedented, and Treasury Secretary Wolcott remained just intrigued enough to wait. January 1801. Washington, D.C. Whitney finally made his move. He brought a box containing disassembled musket locks to a room full of the most powerful men in America: President John Adams, President-elect Thomas Jefferson, cabinet members, military officers, men who could destroy his career with a single decision. Whitney spread the parts on a table: triggers, springs, lock plates, hammers, pans, all the components of 10 musket locks, completely disassembled and mixed together. Then he invited the officials to randomly select pieces. Any trigger, any plate, any spring, he assembled a functioning lock from the random parts, then another. He asked Jefferson himself to choose components. The lock worked perfectly. But here's the real kicker. Whitney produced more parts made by different workers on different days in his Connecticut factory. He assembled working locks from those too. The room went silent, then erupted. Jefferson, already fascinated by manufacturing theory, peppered Whitney with questions. Military officers remained skeptical but couldn't deny what they'd witnessed. The contract was extended, more funding approved. Whitney had bought himself time. Except here's the thing. It was partly theater. The parts weren't as perfectly interchangeable as Whitney claimed. They were close, impressively close, but not perfect. He'd carefully selected pre-fitted components for the demonstration. Some hand filing was still required. The concept was proven. The execution still needed serious work. Whitney had demonstrated the future, now he actually had to build it, and that was going to take a lot longer than anyone expected. The reality of Whitney's factory between 1801 and 1809 was messier than the mythology suggests. Production was slower than promised. Parts weren't as interchangeable as claimed. Workers still needed to do hand fitting on many components. Training the workforce proved harder than expected. Equipment broke down. Whitney spent those years constantly renegotiating deadlines, writing apologetic letters, promising imminent delivery. The final muskets weren't delivered until 1809, 8 years late. The government was frustrated but remained patient, and here's why. They understood, perhaps better than Whitney himself at first, that they weren't just buying guns. They were funding research and development. They were investing in a completely new way of making things. What Whitney actually achieved wasn't perfect interchangeability. That would take decades more refinement. What he created was the system for achieving it. The machines, the jigs, the division of labor, the concept of tolerances and measurements. He proved it was possible. More importantly, he created a template that others could study, copy, and improve. Springfield Armory in Massachusetts and Harper's Ferry Armory in Virginia adopted Whitney's methods and pushed them further. An inventor named John Hall, working at Harper's Ferry in the 1820s, actually achieved true interchangeability. His rifle parts fit together without any hand filing at all. Hall built on Whitney's foundation, refined the techniques, added innovations of his own. By the 1840s, what became known as the American system of manufacturing was internationally recognized. European observers visited American armories and left astonished by the precision and scale they witnessed. But here's where the story gets really interesting. The principles jumped from weapons to everything else. Clockmaker Eli Terry applied interchangeable parts to make affordable clocks. Cyrus McCormick used the system for agricultural equipment. Isaac Singer for sewing machines, Remington for typewriters. Whitney's original vision was interchangeable parts for everything, not just muskets. By the 1850s, it was happening across American industry. The American system gave the United States a genuine manufacturing advantage globally. European craftsmen could still make finer individual products, but American factories could make good products in vast quantities at lower prices. Standardization, interchangeability, division of labor. These became American manufacturing's signature strengths. Whitney himself got wealthy from government contracts and private ventures. He died in 1825, celebrated as a genius, a visionary, a founding father of American manufacturing. But there's a paradox here: he overpromised and underdelivered. The mythology that the story of perfect interchangeability from day one exceeded the reality of incremental improvement toward a distant vision. Yet the vision mattered more than the execution. Whitney sold America on a future, and then other engineers, mechanics, and inventors built that future. He didn't perfect interchangeable parts. He convinced people it could be perfected, and once you believe something's possible, once you've seen even an imperfect demonstration, stopping becomes impossible. The question is whether that future was entirely good, because the same system that made clocks affordable also made war industrial. In 1861, the American system faced its ultimate test and its darkest application. The Civil War erupted, and suddenly both Union and Confederate armies needed hundreds of thousands of weapons immediately. Springfield Armory alone produced over 800,000 rifles during the war. Harper's Ferry, before it was destroyed, had been churning out weapons using Whitney's methods for decades. The interchangeable part system meant battlefield repairs were possible, deployment was rapid, and armies could be sustained indefinitely, as long as factories kept running. The war was only fightable at this scale because of the manufacturing capabilities Whitney helped create. Before interchangeable parts, armies were limited by weapons availability. Wars were shorter, casualties were lower, relatively speaking. After Whitney's revolution, industrial-scale killing became possible. Here's the uncomfortable math. The Civil War killed between 620,000 and 750,000 Americans. The Minié ball bullets used in most rifles benefited directly from precision manufacturing. Consistent parts meant consistent accuracy, and consistent accuracy meant more deaths. The same precision that made factories efficient made warfare industrial. There's no way around this complexity. The American system spread globally after the Civil War. European nations adopted it. British armories studied American methods and implemented them. By World War I, every major power was using interchangeable parts, manufacturing for weapons, vehicles, and aircraft. The scale of destruction in that war, the millions of artillery shells, the endless supply of rifles and machine guns, all of it depended on the manufacturing principles that traced back to Whitney's Connecticut factory. World War II took it further. The entire Allied war economy was based on standardized parts, assembly lines, and division of labor. The arsenal of democracy, America's staggering wartime production, was a direct descendant of Whitney's vision. Tanks, planes, ships, jeeps, all assembled from interchangeable components made in factories across the country. It won the war. It also enabled a level of destruction previously unimaginable. Whitney set out to help America defend itself. He succeeded. But he also created the foundation for industrialized warfare on a scale that would have horrified him. The same principles that enabled automobiles, refrigerators, radios, and telephones also enabled machine guns, bombers, missiles, and eventually nuclear weapons delivery systems. Innovation is power. Power is morally neutral. The choice of application is entirely human. Was Whitney responsible for how his methods were used? He died in 1825, long before the Civil War, decades before the World Wars. Did he foresee these consequences? His writings suggest he saw interchangeability as progress, as efficiency, as democratization of manufactured goods. The military application was a means to an end, a way to fund the development of something larger. But intentions don't control outcomes. Whitney wanted to make things affordable and accessible. He succeeded beyond his wildest dreams. He also made war affordable and accessible at industrial scale. Both realities exist simultaneously. Progress is never clean. The tools we create outlive us and serve purposes we never imagined. Look around right now. Every manufactured object you see exists because of interchangeable parts. Your phone, laptop, furniture, vehicle, appliances, all of it. The specific components might be different, the technology advanced beyond recognition, but the underlying principle is Whitney's, not because he perfected the system, but because he proved it could be done and created a pathway for others to follow. The lineage runs clear from Whitney's filing jigs to precision machine tools to Henry Ford's assembly lines to industrial automation to robotics to computer-aided manufacturing to modern 3D printing. Each innovation builds on the foundation of interchangeability. Today's CNC machines are doing exactly what Whitney's jigs did, holding parts precisely and ensuring consistency, just with digital precision measured in microns instead of mechanical fixtures measured in thousandths of inches. Same principle, evolved execution. International standards organizations like ISO, ANSI, and DN are all descendants of Whitney's core insight that things must be measurable and consistent to be interchangeable. Every technical specification, every tolerance marking, every manufacturing standard in use today traces back to the realization that parts must be truly identical for mass production to work. Global supply chains only function because a factory in Taiwan can make a component that fits perfectly with parts made in Germany and Mexico. That's Whitney's world, scaled to planetary dimensions. His real vision was democratization, making goods affordable and available to ordinary people. Before interchangeability, products were expensive because they required skilled craftsmen working for hours or days. Repairs were difficult because replacement parts didn't exist. Replacement was impossible because each object was unique. After Whitney, mass production drove costs down dramatically. Repairs became possible with standard parts anyone could order. Accessibility increased exponentially. Whether that's entirely good is another question. We gained prosperity and lost craftsmanship. We got abundance and created disposable culture. We achieved efficiency and maybe lost something human in the process. Environmental consequence of mass production, the mountains of waste from products designed to be replaced rather than repaired, the global supply chains that exploit labor and burn fossil fuels, all of that is part of Whitney's legacy too. We live in the world Whitney helped create, the world of interchangeable parts, mass production, and industrial scale. It gave us both prosperity and destruction, abundance and waste, efficiency and dehumanization at factory speeds. The question isn't whether Whitney's vision was good or bad. It's what we do with the world that vision created. So next time you replace a battery, swap a broken part, or benefit from any mass-produced object, somewhere in that moment, Eli Whitney's gamble lives on. Not because he perfected interchangeable parts, he didn't. Not because he delivered on time, he was 8 years late, but because he convinced America it was possible. He demonstrated the future in a room full of skeptics in 1801, and that demonstration changed everything. Once you believe something's possible, once you've seen even an imperfect version of tomorrow, stopping becomes impossible. Whitney didn't build the modern world alone, but he showed us the blueprint. What we built from those plans, for better and worse, that's on all of us.